Hey there, class. Mr. Bosky here. Hope you're having a good day so far. We're continuing with Chapter 7, which is linear systems. And so we talked about at 7.1 about solving linear systems by graphing and seeing where they cross. That's going to be a solution. Today we're talking about substitution. And so basically substitution and linear combination, actually it's better known as elimination, are two ways to solve algebraically to see where the two graphs are going to cross, okay? Basically by manipulating equations and kind of plugging stuff in and solving, okay? So our name of the lesson in 7.2 is solving linear systems by substitution. Our central question is, how do we solve a linear system using substitution? All right, well, solving a linear system using substitution, step one is to solve one equation for one of its variables if necessary, and you want to pick the easy one to solve for. Pick the easy one to solve for. Okay? Step two is to substitute. Substitute the expression from step one into the other equation, then solve for the other variable. Step three is we're going to plug the value from step two into one of the original equations, and we're going to solve for the missing variable. And your answer is an ordered pair, and check the solution in both equations. Your answer is the point of intersection where they cross or intersect. And an ordered pair is something like 2, 4. That's an example of an ordered pair. Okay? All right, let's get right into it here. So, those steps are kind of abstract and they're just words. So let's see what it means to actually do it in a problem here. So it says solve the linear system. And we have example 1. It says 2x minus 7y equals 8 and y equals negative 6x minus 20. Okay, so the substitution is literally we're going to substitute. We need to make sure first that x or y is by itself. Do you see in one of these equations is x or y by itself? Hopefully you see in the bottom equation that this one has y equals, that y is all by itself down here. So I'm going to erase that, you won't see it. But y equals negative 6x minus 20. So y is by itself, so that's a good thing for substitution. So now we're literally going to take y equals negative 6x minus 20. So it's totally okay to take this, and we're literally going to take it, we're going to plug it in for y, because y equals that. That's a legit, that's called a substitution property, okay, of equality. You can take, if something is equal to something else, you can plug it into the other equation because it's equal to that. All right? So now I'm going to rewrite the 2x minus 7y equals 8, but I'm going to write 2x minus 7, I'm going to replace the y with negative 6x minus 20, and that equals 8. Okay, so right here, we still have 2x minus 7y equals 8, but y equals negative 6x minus 20 here, okay? I'll write it below there, actually. We'll put y down here, okay? This is still minus 7y, but in this case, y equals negative 6x minus 20. Okay, so now we're going to solve for x here. We're going to get x by itself. So the first thing we need to do, we need to solve this equation. So the first thing we do when we solve is we need to simplify, which means we need to do two things. We need to both, can you remember what they are? We need to distribute and combine like terms. So first things first, is there anything to distribute here? Yeah, we got the negative 7 to the negative 6x and negative 7 to the negative 20. So we have 2x. What's negative 7 times negative 6x? That's positive 42x. What's negative 7 times negative 20? That's positive 140. Equals 8. Okay. Anything else to distribute here? No. Any like terms to combine? Hopefully you said yes. We have 2x and 42x are like terms. What's 2x plus 42x? Well, that's 44x. Plus 140 equals 8. Any other like terms? Nope. Now we need to get x by itself. What's the first step to getting x by itself? Well, we're going to get the 44x by itself, so we're going to subtract 140 from both sides. So we get 44x equals, what's 8 minus 140? Well, that's negative 132. You can just use a calculator for that if you need to. What's the last step to solve for x? Well, we need to divide by 44. So we're going to get x negative 132 divided by 44 is going to be negative 3. Are we done? We solved for x. Are we done with this problem? No, we need an ordered pair like x and y. We need something like in parentheses like this. We have our x as negative 3. Let me write that better. But we need to write an equation with, we need to write our y. We need to find our y now. So we're going to take this negative 3 now, We're going to plug it into y equals negative 6x. Let's write that better too. Negative 6x minus 20. We're going to take this negative 3, and we're going to plug it in for x. A lot of substitution going on here. All right, so now we have y equals negative 6 times negative 3 minus 20, because x equals negative 3, so we're not changing it. This is still x right here. All right, what is negative 6 times negative 3? Well, that is positive 18. And what's 18 minus 20? That equals negative 2. So our final answer is going to be negative 3, negative 2. This is our final answer by substitution. So if you were to graph both these lines, you would get negative 3, negative 2 would be where they would cross. Okay? All right, let's talk about example 2 here. So, example 2, it says 8x plus 4y equals negative 8 and negative 2x plus y equals 2. So, first things first, we need to get x or y by itself right now. Is x or y by itself in either of these equations? The answer is no. We have two things on the same side of the equal sign. We have both x and y on the same side of the equal sign, so that's not going to work. So, which one will be easier to solve for x or for y for, do you think? Hopefully you said the bottom. I would get the bottom one by itself because we have a 1y right here, which is really going to be easy because all we have to do is move that 2x to the other side, negative 2x to the other side. So let's do that. How do we move negative 2x to the other side? We're going to add 2x to both sides. So now our new equation, now we just have y equals 2x plus 2, which is really easy to solve. If we solve for x on the top, we would have to subtract 4y and then divide by 8, and we could probably get some fractions. Whereas if we have just one y like this, it's the one you want to make your life easier. You know what I mean? Okay, so now y is by itself, which is good. So now we're going to do, it's literally called substitution. So wherever we see a y, we're going to replace it with 2x plus 2. So we're going to go in the other equation, and we're going to plug in 2x plus 2 in for y. So we have 8x plus 4 times 2x plus 2 equals negative 8. All right, and now we need to solve this. We have all x's, so we can solve this. Anything to distribute here, first of all? Yes, we got to distribute the 4 to both of these. So we have 8x. 4 times 2x is 8x. 4 times 2 is 8 equals negative 8. A lot of 8's going on there. All right, anything else to distribute? No. Any like terms to combine? Yes, we have 8x and 8x. We're going to combine these like terms. 8x plus 8x is 16x. Plus 8 equals negative 8. Any other like terms? Nope. Now we need to get that 16x by itself, so we're going to subtract 8 from both sides. What's negative 8 minus 8? It's negative 16. What's the last step to solve for x? Divide by 16. So x is going to be equal to negative 16 divided by negative 16 is negative 1. Are we done? Is that our answer? The answer is no. We have x equals negative 1, but that's not our answer. We need to plug that into one of the original equations. I'm going to plug into y equals 2x plus 2, but you could easily plug into 8x plus 4y equals negative 8 or negative 2x plus y. You can plug into either of these or our new equation, which we're doing right down here. Either one would totally work. All right, so let's plug in negative 1 now. We're going to take this negative 1, we're going to plug it in for x. So y equals 2 times negative 1 plus 2. Negative 2 times 1 is negative 2. And negative 2 plus 2 equals 0. So y equals 0. So our final answer is not just x equals negative 1, y equals 0. Our final answer is negative 1, 0. It's a coordinate. These are coordinates where the lines cross. Okay, it's not just x equals y equals. It's the negative 1, 0 is going to be your solution. All right, sounds good. We're talking about a word problem now. So systems are actually really nice for word problems because you can figure out which, it's just really good for word problems. You'll see why in a second here, okay? We're going to do one word problem, then we'll try a couple more on our own. We'll probably call it a day. So, all right, sounds good. You are selling tickets for a high school play. Example 3. Student tickets cost $4 and adult tickets cost $6. You sell 525 tickets and collect $2,876. How much of each type of ticket did you sell? Okay, so we're going to need, we're going to call X and Y what we're looking for here. All right, so we have two types of tickets here. What kind of tickets do we have here? Well, we have student tickets. X equals student tickets. We'll just call it that. And we're going to call Y as adult tickets. Usually X and Y are going to be what you're looking for, so you're going to call it X and Y. Because we're looking for how many of each type of ticket that we sell. All right, we need two equations now. So we need two equations for these kind of problems. So with these kind of problems, so we have two things we're measuring here. We're measuring how many tickets we sold, and we're also measuring how much the cost of each ticket, okay? So what we're going to measure here, one equation is going to be how many tickets, and one's going to consider how much each ticket costs. That's not what I want. One ticket for how many, one ticket for how much. Or one equation, that is, for one how many and how much. Oops. Sorry about that. Okay, so let's figure out a couple equations here. So we sold how many tickets in total? We sold 525 tickets. So if X equals the number of student tickets and Y equals the number of adult tickets, and you sold 525 tickets total, what operation does total mean? Well, total means you're adding them together, right? So our first equation, which is pretty easy, is going to be X plus Y equals 525. X plus Y equals 525. Okay? The second equation is going to measure how much each ticket costs. So how much did a student ticket cost? So the total cost of student tickets is going to be the cost of each ticket, which is $4, times the number of tickets we spent, which is X, plus the cost of adult tickets, which is $6, times the number of adult tickets that were sold, which is Y. And that's going to equal our total collected amount, which is going to be $2,876. I'm going to rewrite these a little bit smaller, actually, I think. So I had some room. So sorry if you're not seeing anything right now, but I'll rewrite these. X plus Y equals 525. And 4X plus 6Y equals 2,876. All right, and now that we have two equations, we have a system here we can actually solve using substitution. So I want to, in the other problems we were solving for Y, it looks like. So in this case, we're going to solve for X. I want to get X by itself. Which equation would be easier to get X by itself for? The top equation. I'm going to get the top equation, get X by itself. I'm going to subtract Y from both sides. So I'm going to get X equals 525 minus Y. Okay, so now we have X by itself, so we're literally going to take this 525 minus Y, we're going to plug it in for X. We're going to plug it in for X. So we're going to have 4 times 525 minus Y plus 6Y equals 2,876. And this is still X right here. We're still replacing X with 525 minus Y, so that's totally legit. We can do that. Okay. Now we need to solve this. Anything to simplify here? Do we have anything to distribute? We do. We have the 4. We're going to distribute the 4 to this and the 4 to that. I'm going to write over to the right over here, actually, too. So 4 times 525 is 2,100. 4 times negative Y is negative 4Y. Plus 6Y equals 2,876. All right. Anything else to distribute here? No? Any like terms? Yep, we got negative 4Y and positive 6Y. So we have 2,100 plus 2Y equals 2,876. Now we need to get the 2Y by itself. So how do I move that 2,100 to the other side? I'm going to subtract 2,100 from both sides. So we get 2Y equals, that 2,876 minus 2,100 is 776. Divide by 2 to get Y by itself. We're going to get Y equals 388 adult tickets. That's one of the answers. In this case, we don't really need an ordered pair because we're trying to actually solve for a word problem here, okay? All right, now we need to find the student tickets. So we're going to plug into our other equation, which was X equals 525 minus Y. So we're going to take this, we're going to plug it in for Y. So X equals 525 minus 388, which equals, X is going to equal 137 student tickets. All right, and there's our word problem. So if you wanted to write an ordered pair, it'd be 137, 388, which is a pretty big point across, but that's also an answer you could put. Okay, we have example 4 and 5, which are you guys can try to solve on your own. We'll go over them in a second. Give them a try. All right, sounds good. Let's get through this here. So example 4, we have y equals negative 5x minus 21 and 4x minus 2y equals 0. So first things first, is x or y by itself in either of these equations? The answer is yes. We have y by itself. So we're going to take whatever y is equal to, we're going to substitute it, because it's called substitution, into the other equation for y. Be very careful, too. Sometimes people substitute it in for the wrong variable, and that messes them up. We're plugging in for y. We're not plugging in for x. It's y equals this, not x equals this, okay? It's y equals negative 5x minus 21. So now we have 4x minus 2 times the new y, which is 5x minus 20, negative 5x minus 21, equals 0. All right, now we got to solve from here. Anything to distribute? Yes, we have negative 2 times this and negative 2 times that. So we have 4x. Negative 2 times negative 5x is positive 10x. Negative 2 times negative 21 is positive 42. Equals 0. Anything else to distribute? No. Any like terms? Yep, we got 4x and 10x, which is going to be 14x. All right, now we need to solve for x. Now we have it equal to 0 here, so we need to either move 14x or 42 to the other side. I'm going to move 42 to the other side, because we can't just set them equal right now, because we need to move stuff to the other side where it's equal. Now we have 14x equals negative 42. How do we solve for x now? Well, we're going to divide by 14. X equals what? Negative 3. Okay. So that's one of our answers. That's actually half of our answer. Half of our answer is negative 3. That's our x. What's our y value? We got to plug into the original equation now. We're going to plug into y equals negative 5x minus 21. We're going to plug in this 3 in for x. So we're going to have y equals negative 5 times negative 3 minus 21. Negative 5 times negative 3 equals 15 minus 21. And then 15 minus 21 is negative 6. So our final answer is negative 3, negative 6. And there's our answer. All right, let's try example 5, last one of the day. So we have x plus 3y equals negative 16 and negative 2x minus 2y equals 16. We need to make sure that x or y is by itself right now. Is x or y by itself? The answer is no, we do not have x or y by itself. Which one would be easier to get x or y by itself for, the top or the bottom? Hopefully you said the top because we have a 1x right here in the front. So I'm going to subtract 3y from both sides to get x by itself. So now we're going to have x equals negative 3y minus 16. Okay, now we need to, now we have x by itself, so we're going to substitute wherever we see an x, we're going to replace it with negative 3y minus 16. So we're going to replace x, not y. We're going to replace x with negative 3y minus 16. So negative 2 times negative 3y minus 16 minus 2y equals 16. All right, now we can solve from here. Anything to distribute? Yep, we got the negative 2 to both of these. Negative 2 times negative 3y is 6y. Negative 2 times negative 16 is positive 32. Minus 2y equals 16. Anything else to distribute? No. Any like terms? Yep, we got 6y and negative 2y, which is going to be 6y minus 2y is 4y plus 32 equals 16. Now we got to solve for y. We need to get that 4y by itself, so we're going to subtract 32 from both sides. 4y is going to equal, it's going to be negative 16. Divide by 4. Y equals negative 4. So we got half our answer here. This does not want to zoom out very nicely. We got half our answer, which is something negative 4. Be careful with how you list it too. Y is negative 4, not x. All right, now we got to solve for x. We're going to plug into x equals negative 3y minus 16. We're going to plug in -4 in for y. -3 times -4 minus 16. -3 times -4 is 12 minus 16. X is going to be equal to -4. So our final answer is going to be -4, -4. I'll zoom out a little bit so you can hopefully see everything nicely. Okay, and that's all I have for you today. It's kind of we only did a few examples, 5 examples total, but they're kind of long problems. And so be gentle with yourself. There's a lot that can go wrong because there's so many steps. Just make sure you keep plugging away and don't give up in the middle of it and just say, I don't know how to do it, because chances are if you make a mistake, you can still kind of finish it to the best of your ability, just so I know that you know what you're doing, okay? So, yeah, thank you for watching. Have a great day. We will talk soon.